Have you ever seen one of those corny action movies where a guy just picks up a rifle, aims at a guy a mile away, takes a shot and hits him right in the head without any sort of calculations? Well, I just want to explain to you how truly impossible that is. Today I will explain to you the importance of distance estimation to making a distance shot and the mathematics behind the formula snipers use to make that estimation. I was taught this formula while serving in the Marine Corps, and I have used it for both direct fire and indirect fire applications. I am sure you have all heard how much skill it takes to be a sniper, and have wondered how they do what they do. This is just a small part of what they do, but it is by far one of the most important aspects of making the shot. Today I will cover why distance estimation is important to the shooter, the different types of distance estimation, what a mill, a radian, and a NATO mill are, and the different types of equipment that can measure a mill and how this applies to distance estimation. Okay, first I want to cover why distance estimation is important to the shooter. And this is about bullet drop. And bullet drop occurs because gravity affects all objects the same, accelerating downwards at 9.8 meters per second squared. The sniper round, the NATO 7.62 sniper round, has a muzzle velocity of 853.4 meters per second. And this was found off Midway USA, who is a manufacturer of the NATO 7.62 round. So for an 853.4 meter shot, the bullet will drop 9.8 meters. For a 426.7 meter shot, the bullet will drop 4.9 meters, etc. So even for a relatively tall person or target, about 6 foot tall, you can see how this is an incredibly important factor. You will actually miss the person. So the way this is done, if this is your target here, directly in front of you, you actually aim high so that your arc will hit the target, if that makes sense. Okay. Now I will cover the different types of distance estimation. You go ahead and hit the lights. I need it again. Okay, the first type of distance estimation is a good guess. How far away does it look? The second method is the halving method, and that is estimating halfway to the target and then doubling it. The next is the football field method, and that is estimating how many football fields you can fit between yourself and the target, which is about 100 meters. And the fourth method would be the laser rangefinder, which you're not going to have, and the formula method using the Mill reticle or compass measuring device. This method is the subject of the speech. This was found off of the Survival IQ Handbook for Scale and Distance. Next, I will cover what a radian, a mill, and a NATO mill are. The radian. A radian, you use the circumference formula, C equals 2 pi r, which is for a full 360-degree circle, divided by the radius, so your circumference is 2 pi radians. I don't want to lose you guys. So pi is 3.14159, so 2 pi is 6.2832 radians in a full circle. It's just a measurement of an angle. It's actually a ratio by, well, I'll explain that later. Okay, the mill. A mill is short for a milliradian, and it's a more accurate way to measure an angle. There's 1,000 milliradians in one radian. So if C equals 2 pi, then in milliradians, C equals 2,000 pi, or 6283.2 milliradians. Since 6283 is not an easy number to divide, NATO devised the NATO mill, which is 6,400. It's just a more round number and easier to divide. So instead of 1 mill being 6,283.2 of a circle, it is now 1/6400th of a circle. You can check with the manufacturer of your equipment that you're using if you want to know the difference. Okay. Next, I'll go a little bit more into exactly how a mill is devised. A mill is a ratio between the arc that the angle subtends meaning comes below. So you have your angle here, which is whatever degrees it is, so whatever piece of that circle it cuts off divided by the radius of the circle is going to equal the angle here in radians. And I give you the formula S over R equals theta, and then I transpose that for you to the way that snipers like to use, to S over theta equals R. It's just a rearrangement, and one thing you need to know is all you need to know is any two of these, and you can solve for the third one. Okay, all this information was found off of a paper written by Robert J. Simeon, who was the author of A Shooter's Guide to Understanding Mills and MOA. Okay, next, let's look at some of the equipment that can measure a mill. You have on scopes on rifles, a lot of times they come with something called a mill dot reticle, and this is a picture of it. And in between each dot is one mill. Also, they have binoculars that have the same type of reticle in it for measuring the mill. And there is also a compass. And a compass is an incredible tool for measuring angles, and we usually have mills and degrees. However, some will only have degrees. And I included the formula for conversion, but I won't get into that now. Okay, this was all found on FM 7 TAC 8, a military manual of operations. And now I will get into the whole point of the speech, and that is how it all fits together. First step, estimate the size of the target. For a 6-foot man, he is approximately 1.8 meters or 2 yards high. Passenger car, 1.3 meters or 1.4 yards. For a building, each story is about 10 feet, 3 meters, 3.4 yards, etc. So all you need is a good estimation of what you're looking at. Second, you measure the angle in mills using one of the devices talked about earlier. Okay, so you measure that angle that's subtended in through your scope, through your reticle. Then you divide the height or width by the angle it subtends, then multiply by 1,000. Your distance will be in whatever unit you use to estimate the size of the target. This is the simplified version of the formula right here. I'll put it in the center for you guys. And basically everything I've taught you boils down to this one line right here. Can you put the lights on for me? Thank you. Okay, all that information and that formula was also by the author, Robert J. Simeon, from his article. Okay, so now you have a better understanding of why distance estimation is important to the sniper. What the mill is, what the types of equipment that can measure the mill, and how the mill is used to accurately estimate distance. So next time you're watching a Tom Berenger movie and you're really wondering how he just made that shot, you can rest assured you have a better understanding on how that is done. Thank you very much.
All right, so Blake, what did you think?
I think you had a good attention getter, very clear thesis. You had good personal experience. You seemed well informed on the subject since you've been in the military. I like the description of visuals. I like the description. The visuals were good. Or something like that. They helped with the presentation. I like how you presented the equipment as well. I like the detail you got into because it's a topic that needs clarification through statistics and through numbers. Visuals really put the picture to your words. You cited a few sources and your transitions were clear. Lots of information, and it makes me want to research it more. Almost too much info, but you put it all together and you managed. I like how you put reality into the topic. I like the example you gave about the shooting the guy in the head and how it's impossible. I like that you put it all together at the end and put all the numbers and statistics to use. Overall, I think it was very good and it was very informative. So, thank you for helping.